Hi, good day. I am Layok and welcome to webinar 1, Water Management and Treatment. So today's webinar is the first of the webinar series on experience sharing on water and wastewater management and treatment between Singapore and Sri Lanka, which is jointly organized by the NUS Environmental Research Institute, in short NERI, at National University of Singapore, with the Joint Research and Demonstration Center for Water Technology, that is JRDC, under the Ministry of Water Supply and University of Peradeniya, Sri Lanka, together with PUB, Singapore's National Water Agency, as the supporting organization. Without further ado, I would like to invite Professor Hao Yong Ng, Director of NERI, NUS, to give his opening remark. Professor Ng.
Hi, good day, greeting to everybody. On behalf of NUS Environmental Research Institute, we are delighted to have this opportunity to jointly organize the webinar series on experience sharing on water and wastewater management and treatment between Singapore and Sri Lanka, with the Joint Research and Demonstration Center for Water Technology, or JRDC in short, Ministry of Water Supply and University of Peradeniya, Sri Lanka, together with PUB, the Singapore National Water Agency, as a supporting organization. Climate change has brought about many pressing challenges affecting our water security and water quality. Among these, we have been experiencing more frequent and intense unpredictable weather events, such as drought, intense precipitation, high variation in ambient temperature, and so forth. All key stakeholders, including the water authorities, regulators, practitioners, and researchers, have critical roles to ensure our precious resource water is managed sustainably in this climate change era for our daily needs and for the long-term development of our countries. Through this webinar series, the knowledge and experience shared would help foster our understanding on the emerging challenges and learning from each other on the potential management and treatment strategies to address these climate crisis challenges. It gives great pleasure to welcome all of you to today's inaugural event on the topic, water management and treatment, to mark the beginning of our webinar series. I'm very honored to have prominent speakers from the water agencies, academia, and industries from Sri Lanka and Singapore. I wish you have a fruitful session. Thank you.
Right. Thank you, Professor Ng. Next, I would like to invite Dr. S.K. Varagoda, Director, carrying up the for Joint Research and Demonstration Center for Water Technology, JRDC, Sri Lanka, to deliver his opening speech. Yes, Dr. Varagoda, please.
Very much for organizing this very special webinar series, bringing up a lot of opportunities for us to share the experiences in water management and treatment between Sri Lanka and Singapore. So Singapore, we all know that you are doing very well in the world in regards of especially the NRW putting up at the lowest figures, that is 5%. So we are going around 25% right now. So as a country, we like 65,000 square kilometers and having a population of 21 million. So this is sort of like a very good sort of way forward for us to understand how you have reached to this all wonderful figures. So when it's coming to Sri Lankan water management, the government policy has been derived to focus around water for all. So that's a like a sort of challenge that Sri Lanka right now facing. So all the good practices, experiences would be very much beneficial for the water professionals in Sri Lanka. The idea here in China, Sri Lanka Joint Research and Demonstration Center for Water Technology. This is funded by the government of China. It's got about 15 million US dollars, and Sri Lankan government has awarded about 8 million US dollars. So altogether, we got a facility of almost in Sri Lankan rupees, I would call about 600 million worth. That means almost like 2.5 million US dollars worth facility for testing. We got all the high-end equipment available with us now. So that's a very good way forward. And we are located in University of Peradeniya, one of the best universities in this region. And we are supported, we are backed with the expertise coming from University of Peradeniya. So this is what the blessing, the capacity we are holding right now. And the Joint Research and Demonstration Center, JRDC, is under the Ministry of Water Supply. So Ministry of Water Supply is the responsible agency for the country to ensure safe, secured drinking water supply throughout the day. Like so, and again back, I would be so happy to see the PUB partners, NUS partners, all the way that all PUB, NUS, the sort of like we have in a very strong relation between Sri Lanka and the National Water Supply and Drainage Board, the agency for responsible agency for supply and drinking water. So thank you very much for everyone giving this opportunity to us. Thank you, Dr. Ai. Okay. Yes.
Right. Thank you, Dr. Veragoda. Following this, please let us welcome Professor SHP Parakrama Karunaratne, Senior Professor and Chair of Zoology, University of Peradeniya, and also Chairman of JRDC, University of Peradeniya Research Committee, Sri Lanka, to share his opening remark. Please, Professor.
Good morning, good afternoon, and I warmly welcome you all to this webinar series on behalf of the University of Peradeniya. Actually, as it was stated, that university, this JRDC, or the Joint Research and Demonstration Center for Water Technology, is located within the university premises, University of Peradeniya. So let me say a few words about University of Peradeniya. It is in the hill country of Sri Lanka. It's in the middle of the country, and it is about, once it was ranked as the 10th most beautiful university in the world. So we have about 2,000 acres between the Hantan mountain range and the Mahavali river, and we have 9 faculties. So it covers all disciplines, and 7 are science-based: science, engineering, medicine, allied health, agriculture, veterinary science, dental science. So all the science-based faculties are here, and we do a lot of research. And we are the rank #1 university in Sri Lanka. And in the Times Higher Education ranking, we are between 400 to 500 in the world rankings. This is the largest university in Sri Lanka, and all the oldest university. It's a residential university, and we have 4 postgraduate institutes inside the university: Postgraduate Institute of Agriculture, Science, Humanities and Social Sciences, and Medical Sciences. So we have about a 25,000 community, both students, staff, and non-academic and academic staff. So we are doing a lot of research here. We have the University Research Council, a lot of research here, and our staff is they have obtained their PhDs from developed countries, and we have a lot of collaborations, and you all are welcome to collaborate with us to do water research. Now we have JRDC, and we do a lot of work jointly on water technology. So that's it I have to say, and I hope that, thank you very much, the organizers, for organizing this, and I hope that this is going to be a very, very fruitful webinar series. Thank you very much.
Right. Thank you, Professor. Yes, so we will begin our sharing session next, followed by the panel discussion and Q&A. Before we begin, I would like to go over a few items. So questions and comments to today's presentations and topics will be addressed during the panel discussion and Q&A session. So you can send in questions or comments by typing your questions into the question pane that is found at your Zoom window during that session. So if there are similar questions you would like to raise or put up, you can, which is similar that has been put up by others, you can click onto the thumbs up to vote for that question. All right. Next, let me introduce Professor M.I.M. Maujud, the chair for the next session and moderator of the panel discussion. Professor Maujud is currently the chair professor at the Department of Agriculture Engineering at Faculty of Agriculture, University of Peradeniya, Sri Lanka. So Professor Maujud has over 25 years of research and teaching experiences in wastewater engineering, water pollution control through bioremediation, constructed wetlands, and integrated water resources management. Now I would like to hand over the session to Professor Maujud.
Yeah, thank you, Dr. Lai. Thank you for the kind introductions, and good morning and good afternoon to all participants and the panelists. I'm very glad to chair this webinar series #1 on the water management and treatment. Thank you for giving this opportunity. Thank all the organizers for giving me this opportunity. There are many organizations involved in this webinar series. I must thank them for giving this opportunity. Okay, now I am getting into the session. We have 3 key presentations on very important topics from 3 specialists. So straight away, there is 15 minutes for each presentations. First, I would like to invite Dr. S.K. Veragoda. Already he was in the opening remarks. If I want to introduce Dr. Veragoda, he is my friend, and what I can say, he's academia, he's a researcher, he's a policymaker, he's a practitioner. So what else we can say about him? He's a very niche person on this whole field of water management, right? So it is very good to have him on the first presentation. Dr. S.K. Veragoda, Director covering up JRDC Sri Lanka, would like to talk on water management and treatment in Sri Lanka. Now it is over to you, Dr. S.K. Veragoda. And
Thank you.
each presentation will be given 15 minutes.
Thank you for the very interesting, introduction about myself. So let me share my. In the meantime, I think Professor Maujud, you can see my screen.
Yeah, I can see. Yeah.
Yeah. Okay. So Professor Maujud, for the time being, I'll just switch off my camera, and I'll just go through the presentation.
Thank you. Yeah.
Okay, thank you. So this is about the water management and treatment in Sri Lanka. So get the content for the presentation. I will talk about the water environment in Sri Lanka. Sri Lanka is famous, and all the way in last couple of years, Sri Lanka is counted as the #1 tourist destination in the world, that because of the water environment in Sri Lanka. So let me get little about the water management. Then the drinking water supply and future targets, water pollution and challenges right now we are facing, and research directives to improve drinking water sector. So getting into the water sector in Sri Lanka, in nutshell, Sri Lanka is an island, 21 million of population, and 65,000 square kilometer land area. And the highest point is the Mount Pidurudalagala, 2,882 meters. And the longest river is River Mahavali. I'm just sitting in front of the River Mahavali in a wonderful place located in within the University of Peradeniya. And Sri Lanka having 103 river basins and about small to medium scale 30,000 tanks, man-made tanks. And when you take the whole country area, 4% of the country area is covered by water bodies. So Sri Lanka is blessed with 2 monsoons and 2 intermonsoons, and the highest rainfall is about 5,500, 5.5 meters, and it's gone all over in the middle part of the country. And we basically divide country into 2 zones, and as wet zone and dry zone. So as I said, so Sri Lanka is covered with many lagoons, and Batticaloa, Puttalam are the wonderful places with a lot of biodiversity, very rich environment you can see over there. And the highest waterfall is 263 meter height waterfall. That's the Babarakanda in the central part of the country. And very famous one, Dunginda among the tourist, where you can see a lot of water that's coming as a mist all the way. So then the power generation, we are using almost like 30% of the total power generation using hydropower, and waterfalls are one of the sources for that. So then we got a lot of natural, not that much of natural reservoirs actually. We got man-made reservoirs, especially, and again back we have about 6 RAMs identified wetlands. Again back the water environment. So then the man-made reservoirs. So Sri Lanka having a long history of man-made reservoirs, almost like 2000 years of history, and the then recently we got several projects for the dam constructions and all. So almost all these reservoirs, man-made reservoirs coming in history are placed in the dry zone, that to address the water scarcity. And then the Mahaveli, the longest river, has got 5 dams constructed in somewhere after 1980s to take up the major challenges, sharing water in between wet zone and dry zone. So this is what the basic water management in Sri Lanka in nutshell. So if I just get a summary, so currently we are having about 9,000 to 10,000 million cubic meter storage capacity, but still we are losing about almost like 55,000 million cubic meter of water without having a use. That's the one of the biggest challenge right now Sri Lanka is facing. So Sri Lanka thinking in different directions. They want to go for trans boundary sharing water between basins, like so. Then they are having a lot of other ideas of putting up different thoughts, views of increasing this water capacity, or going for the catchment management and so on. So in Sri Lanka, the irrigation water is being managed by the irrigation department, and the river Mahaveli having its own authority, Mahaveli Authority. When it is coming, drinking water, this is the today focus for us. So we are having National Water Supply and Drainage Board and Department of National Community Water Supply. So these both agencies are under the Ministry of Water Supply, under the Cabinet Minister. So then we have local authorities who are running some facilities around the country. So when it is getting into the water board, National Water Supply and Drainage Board, they got 344 water supply schemes. And right now we have basically conventional water treatment. So for the time being, we are moving towards the very first reverse osmosis desalination treatment facility in the northern province. So probably in future, there could be more to come. So this is of capacity of 24,000 cubic meter per day and funded by ADB. And that is basically, that's under the construction stage now. Other than that, we got 334 water supply schemes. The largest in Colombo is about 500,000 cubic meter production per day, Ambatale we call. Then going around the scale from coming from like 500,000 to 5,000 around. So it's spread all over the way in the country to cover 42% of the total population right now. In addition, 10% of the populations are being covered by 4,500 small scale. That's the community managed water supply schemes. And these all are integrated by the Department of National Community Water Supply. So then, as I said in the introduction, the current government has decided to move forward and bring the coverage, the safe drinking water coverage through pipe-borne water and the guaranteed water supply systems to bring up that into 100% of the total population by 2025. So this is what the national policy. So keeping that in mind, so government has made this diagram to bring up the water coverage from the current situation to 2025 to get the total population covered as shown here. So this is the idea of the government. And basically right now we get about 50% pipe-borne water, almost like 52% maybe. So protected domestic wells are covering about 36%, and tube wells almost like about 3%. So the tube well, that what we go for the deep groundwater, we touch in almost like about 100 to 120 meters, not like many other countries. They go for about 500 to 1000 meters, but we don't find the drilling capacity, and we are trying to improve that up to 200 meters in near future. So this is what the targets in Sri Lanka. So the National Water Supply and Drainage Board trying to put up from 50% to 75% of the total population by 2025. Then the Department of Community Water Supply through the community-based organizations and the domestic systems, that the individual household facilities, they're going to get the balance 25%. So this is what the idea for the whole coverage. So in figures, we are having almost like 2000 plus cubic meters treated all the way per day and distributed through the pipe-borne network, and we want to increase that by another same amount by 2025. So the number of families that we are targeting and to cover as given, and the connection household almost like 2.4 million, and hopefully it will be 4.5 million in 2025. So this is the idea, and the length of the distribution of pipe-borne water in Sri Lanka is about 44,000 kilometers of pipe network, and probably another 30,000 plus will be added into the system in 2025. So Sri Lankan government, the water sector in Sri Lanka got very busy because you got another 4 years to go, and we are targeting 30,000 additional kilometers of pipeline within the country. That's a huge challenge as water professionals. So the government facing a lot of challenges to reach this. It's not just finance, not just the skill, technologies, but as well the water resources and all. So then government has put forward their ideas, mind to bring up a lot of policy level intervention, putting up all the ties all the way, all the directions to release the pressure in the water among the water professionals. So this is what that the government is trying to do. So finally, the main target is to bring up properly managed water sheds. That's what the target, because pollution one side you are doing, the other side you are treating. That's nothing that what we have to do. So if you can minimize the pollution at the water source, that is what the major plan. So Sri Lanka do not find so nicely managed urban policies, urban planning. So that's make a lot of troubles when you are trying to see the water supply in the country. So that's we have to keep in mind. So I just thought to bring the water treatment concepts in Sri Lanka, putting up a one single treatment facility. This is more or less the same for the time being, other than the reverse osmosis plant that what we are going to do very first in the country. That's another 3 years to get the plant in operation. For the time being, we have the treatment facilities with the conventional, you all know. So this is one that I got myself involved in central of the country in tourist area. You may have heard about the Lion Rock. So the Lion Rock area is being fed by this particular treatment facility. So we take water from a lake, or that is diverted from the longest river, Mahaveli River, to the dry zone from wet zone, and the capacity is 30,000 cubic meter. And intake, we got a one screen that called Johnson screen coming from Australia. The opening size with a sort of opening size of 3 millimeter. That's to avoid whatever the floating objects coming into the plant. So then the basic aeration, then the flax mixing chemical addition. We are using alum. Then we are going for PaCl, polyaluminum chloride. Then more or less couple of cases we have the pH correction with lime. Then we got the basic sedimentation with lamella clarifiers. In this case, we have the tube settlers, we have the pulsators, we have the pulsar tubes, we have the super pulsators. So these technologies coming from different part of the world is available right now in the country, but these all coming under the conventional water treatment. So if you take the filtration, of course, we go for the rapid sand filtration, as well as couple of cases we find pressure sand filters also. And the rural scale, we find the slow sand filtration and rough-in filters as well. But in the urban cities, it's more or less like getting with the rapid sand filtration. So then the treatment, what treated water is being distributed through the gravity and pumping systems. So nowadays we are moving towards this granule activated carbon filters as well. That because we have a challenge of treating the water with relatively high organic agrochemicals. So we are moving towards that DAC, granule activated carbon, and couple of cases powdered activated carbon as well. So this is the water treatment process available around the country in more or less like the same throughout the way of this all. So if someone asks whether the Sri Lanka having the what say the access, the all citizens in Sri Lanka having access to safe drinking water, this is the world map just as a sort of eye opener for us to see the water pollution, groundwater, because though we are getting 55% of the population are being fed through pipe-borne water, still about 45 having the sources from groundwater. So that is what they got, the dug wells, they got the tube wells, maybe about 1% to 2% might be relying on the rainwater harvesting. So one could ask a question like this. So this recently, this was published about the groundwater pollution in Sri Lanka. So telling about the nitrate pollution, telling about the fluoride, telling about the like, I mean, the coliform, that because of the poor management of the septage in certain areas, because we have the domestic managed septage systems like with the soakage pit and the septic tank system. So somewhere in Sri Lanka, the groundwater table is being raised up. So you can't manage the minimum gap at least between the soakage pit and the groundwater table, especially in the wets during the wet zone, rainy period, especially in the rainy period. So that make troubles to us. So, and Sri Lanka, unfortunately, is being recognized as one of the mostly challenged country by the climate change, adverse impacts. It was ranked as the world's second mostly affected country in the world in 2018, and 19 it has been shifted to 6. So still we have a lot of challenges, almost like 1 billion rupees worth agriculture products, US dollars, we lost in last decade. So that's the challenge. So this aggravated a lot of things because the survival of the bacteria under elevated temperatures, maybe people moving towards less secured alternative sources, this all bring a lot of challenges to us. And that is why the government has taken a decision to put up the JRDC, the Joint Research and Demonstration Center, with a lot of testing capacities to address these all challenges. While we are meeting the water quantity island-wide, so in the meantime, we have to bring up these all professionals in country to meet the water quality challenges. So that is what the consent and University of Peradeniya we are located, and we got a lot of very renowned professionals who are working in groundwater pollution. And I mean, like, there are a lot of studies going around now. So this is about the inorganic pollution, and Sri Lanka is known for one of the critical challenge coming with groundwater. We suspect it's getting from groundwater, telling us chronic kidney disease. No one knows exact reason, but they focus around 30 plus hypotheses and 20 about coming from groundwater, and they were focusing arsenic or cadmium. So this is the distribution of arsenic in the country, and luckily we don't find arsenic in the central part of the country, only in the coastal zone. The maximum is recorded as 66 microgram. The WHO says the 10 is the limit for WHO. So then some other consents, like, so when you take about the organic pollution, so we know that organic pollution is not known to us so far, and even the natural organics, that might be some challenges, having putting up some challenges. This is one other research getting from JRDC about the combination complexations of organic and inorganic, and how that can get through the human body and penetrate into the kidneys, focusing this as a national interested project. So then about the trihalomethane, because as I said, so trihalomethane is one of the challenges that we find all the way in the treated water, because we are going to the chlorination. So chlorination all the way having a chance of reacting with natural organic matter, DOC. So then it may come up with THM that can cause cancer. So this is also that we have another interest, and Sri Lanka is putting forward their thoughts, ideas, and especially in the water management, in the distribution systems. If you go for a lone retention rather than having centralized chlorination, we do think of going with the decentralized chlorination, with the booster chlorination. So this is one other that we are trying up here in Sri Lanka. So then country has taken a lot of initiatives to go with organic farming, but still it's a huge challenge. And we find that couple of cases coming up, and these organic pollutants, agrochemicals have been recognized and as like that getting as one of the crucial issue in groundwater pollution. So when you are addressing the safe drinking, of course that you have to you have to think of this, and you have to address this. Then moving towards the antibiotic resistant bacteria, of course Sri Lanka had some research done about this, and we are moving forward to go for further studies, because WHO putting up alarms telling that by 2050 10 million of the people may die because of the antibiotic resistant bacteria. So we have some collaborations with international partners as well. So then moving towards some other thinking about the microplastic. So we are putting up another research here with Japan to bring up with University of Peradeniya, JRDC all together to see how that the microplastic, the availability, the existence of this in our water bodies, water environment. So this is another thought of putting up this all. So on top of that, there are a lot of incidents happening in the country because of unorganized, unplanned activities, and spilling of oil is one of the regular event that we observe. So water management, drinking water supply is being challenged through these all activities, by these all activities. And in regards of addressing this groundwater pollution, we are trying our best to get the best technologies, and we do work with Singapore as well to see how that we can improve the groundwater treatment technologies available in dry zone. So nanofiltration is being recognized and introduced recently, and it is well in place. And in addition, when you get the pipe-borne water, so the RO or nano might not get as a feasible financial solution for us. So we are moving towards the electrodialysis reversal technology, and we are in the place of we are in the right now we are trying to put up this EDR as a sort of new technology to treat groundwater in the dry zone. So then on top of that, we are trying to introduce the rainwater innovative techniques for harvesting and sponsity coming from Beijing. China is one of the another application that we have just done some piloting here in the country to address the rainwater harvesting, because Sri Lanka having relatively high amount of rainfall throughout the year, even in the dry zone, about 1 meter to 1.5 meter. If you can manage this well, so probably that would be a good solution for us to address the climate change impacts. So as the last slide, we had a very good project between NUS led by Professor N. So happy to have Professor N today with us, Dr. Layoke, and PUB. This brought up Sri Lanka a novel concept of water safety plan. We learned water safety plan from Singapore for the very first time in 2012, 11, and the APN grant. And now Sri Lanka has been recognized, as you can see in the map. So that's in the green color, WSP policies or regulations under development. Thank you very much, PUB. Thank you very much, NUS, all the professionals for bringing up this opportunity. And we are got almost like 80% of the water supply in the country is covered with 11 step of this process, the approach, water safety plan. Keeping that as a note, and thank you very much, everyone. Thank you.
Yeah, thank you, Dr. Veragoda, for giving a brief introduction on this water management treatment in Sri Lanka, and you have opened up many research areas and ideas. So we will come back to your presentation in the Q&A session. So please be there. And also I ask all the participants to raise their questions in the question answer box. Okay, so we will move to the next presentation by Mr. Aik Numpua. He is a Chief Specialist Water Treatment, PUB Singapore's National Water Agency. And he is a very good excellent experience to how to convert the research output to a practical application. So you are welcome. We welcome Mr. Aiknum Pua for sharing your thought on water management and treatment in Singapore. So let's welcome Mr. Pua.
Thank you very much. Let me share my screen. You can see my screen now?
Yeah.
Okay.
Please go ahead. We can see your screen.
All right. Thank you very much. And a very good afternoon to all. And also a thank you to NERI for the invitations to speak in this forum. Right. My name is Point Nam and I'm from PUB. Right. I'll go straight ahead on my presentation. Okay, that's it. So I will share with PUB's experience or Singapore experience in water supply management and treatment. Let me start off with an intro to Singapore. Now, as you know, Singapore is a very tiny island state, right? That located in the tropics, and I think like Sri Lanka, I think we have plentiful of rain. In Singapore, actually, we have about averaging 2.2 to 2.4 meters of rain annually. So this is a lot of rains, right? And Singapore shouldn't be short of water. However, in the World Resource Institute 2015 report, right? They rank Singapore, it will be one of the most worst water stressed country in the world by 2040. So it's quite intriguing, right? How it is so. Now, as you know, Singapore has about 5.5 million population, and it has to be housed on a land no larger than 725 square kilometers. This is probably slightly more 10% of Sri Lankan land size. So it is the lack of land that actually restricted the capacity for Singapore to store the amount of rains that falls on the land. And despite the management of the reservoir, a lot of the water had to run off into the sea. So we have to, like I said, think out of the box solution. How do we then, going into the future, right, continue to secure water supply for the community and also for economic growth? And this is where we have to think, how do we manage the water resources? I want to talk a little bit of history, going back to 2008, in the inaugural Singapore National Water Week. We have the honor of our founding father, Mr. Lee Kuan Yew, who was our first Prime Minister. Now, he made a very striking statement, and I quote, right? He said, this means water dominated every other policy. Every other policy had to bend at the knee of water survival. Now, I think this is a very powerful statement that provided a very strong political view, right? That for the whole of government effort to move towards creating a water master plan, right? That integrated, into the urban planning, and this has to be a joint effort. I also want to quote another of our prominent personnel, right, Professor Tommy Koh. In the same conference, right, he also mentioned, right, in order for us to manage it optimally, right, each government should have only one minister in charge of water, right? In 1963, when PUB was formed, it was a statutory board named Public Utility Board, typical of a utility agency that is in charge of coordinating electricity, gas, and water, and was then part under the Ministry of Trade and Industry. So in 2001, right, PUB was reconstituted and formed as no longer Public Utility Board, but actually we call it our Singapore National Water Agency, which is what you know now. And this brings together the so-called consolidation of all water management function under one roof, which is the key solution to our water sustainability. So PUB was then reconstituted then. So PUB now has the capability to manage the entire water loop. So as I showed in the slide here. In other words, PUB now manages not only the water runoff, that means that from the rain, it also collects, treat, supply to the community. Then we collect back the water as used water, we call it used water, and treat it. Then of course, in the normal hydrological cycle, right, it goes back to the sea. So we have, this is, I consider as a first drop of water. I always talk to my audience that once PUB is formed, right, every drop of water that fall from the sky belongs to PUB. So we need to think of, that is not enough, as I mentioned earlier, right, we have limited land, and this is so much we can store. In the whole of Singapore catchment, right, it is just like we have one glass of water. I can manage the catchment whatever way I can, right? I will only still have that one glass of water, of probably 100 ml of water. If the rainfall 200 mils, I still can only collect 100 mil, and we have to let go the other 100 mil. So we have to shortcut the whole system as our solution. And this is to collect back. First step, our second drop of water is to collect back all the used water and recycle back to the community and not to the sea. In so doing, right, we are able to take away at least 80% of our so-called 20% of the water that is rejected, and then recycle them back, as well as those water that is being used in the community. We estimated that a single drop of water that is recycled, we can recycle that drop of water 20 times before it disappears. So this is a good avenue for increasing our water resources. That is one second drop. Now we need to think of, is it enough for future use? The answer is maybe not. So we have to look at where is our third drop of water coming from, and that is from the sea. Singapore is surrounded by the ocean, the sea, so there's plentiful of seawater. All we need to now is to convert seawater to drinking water, and that's where we started desalination. So with these three motions, right, we actually effectively close the whole entire water loop that allow us to collect all the fresh water and seawater to treat into drinking water as one increased water, and further enhance the increased water by recycling our water. Now, PUB being an agency now control of the entire water loops. All water matter is under the jurisdiction of PUB or the ministry. Then we're able to then improve the efficiency of our water system on the system level, right? And control all water quality from source to tap. And that way, we tighten the water security to ensure that all water are adequately treated, recycled, and for drinking purposes, and also for industrial use. So effectively, we are able to achieve our key strategy of we capture every drop, we reuse water endlessly, and we desalinate the seawater. That would be our main function of management of our water supply. And effectively, by diversifying this source of water, right, we created our 4 national taps, right, including imported water, the water from catchment, new water, and desalinated water. I will talk about imported water later. Let me go first to the first national tap. This is our local catchment, and we have 5 treatment plants that treat water from the local catchment for drinking purposes, right? That's our first natural tap. The second tap is actually also surface runoff, but is imported from our neighbor Malaysia North in the north. We have an agreement with the Malaysian government to tap water so that we can send the water down to Singapore. And this agreement actually will expire in 2061. Once that day come, hopefully we'll be able to extend. If not, our dependency on the recycling water and seawater will go up, right? And which I will talk about it later on. And this is the second tab. The third tab, of course, is our we call it the new water, the recycled water, which advanced processes to treat it into a drinking drinking standard. And lastly, of course, our desalination. Currently, we have already 4 plants in operation, and the 5th desalination plant will come online this year in 2022. Right. So this is our latest desalination plant that has started operation. It is called the Marina East Desalination Plant. The design of this plant has some uniqueness in it. Now, it actually incorporated a features that was demonstrated through our research and development effort. We call it the variable salinity plant. That means that this particular desal plant, right, has 2 modes. One mode that you can switch to treat surface water, and the other mode switch to seawater. And the intention really is that, as I mentioned just now, we have plentiful rain to a point whereby even after we store up to the maximum prim of our reservoir, we have to let go the fresh water, the rainwater. Now, the idea of this dual mode desalination plant really is during rainy season, right? Excess rainwater will not be discharged into the sea, but will be pumped into a desalination plant like this one, and we'll treat it as surface water plant. When in dry weather, as the reservoir drops and there's no more rain, right? This plant can switch to a seawater desalination mode and take water from the sea to treat. In this way, we actually manage the cost of our productions. So what I've said so far, right, is really the hardware of our water management system. What I have not talked about is the hardware or the software part, which I will not go into detail. It actually centers on education, regulation, engagement of our society to try and conserve water. So these 2 functions, hardware and hardware, actually combine to form the whole principle of our ideology of water management for Singapore, right? So I said enough for the water management part. Let me now touch on the water treatment part. I put down water treatment, but I have also entered a word leveraging of technology. As I mentioned, as I go through the slide, I will put a lot of emphasis on the leveraging on technology. How do we go in selection of technology that will best fit the condition in which Singapore is applying those technology, right? As mentioned, I think earlier, typically, I think we started off with a conventional treatment plant that consists of the flocculation, coagulation and flocculation, sedimentation, sand filtration, and chlorine disinfections, right? So this has been working well for us for many years now. Climate change has a lot of impacts on the way in which now we manage our water treatment plant. Now, as the climate change impacts grows, I think in recent years, Singapore is seeing more frequent droughts and more frequent extreme rainfall, resulting in as you see in the two photographs there, we have droughts in 2019 that one of our pond in the Botanic Garden almost dry up. And most recently in August 2021, one of our major roads, in Singapore, Peradeniya roads, right? The heavy rainfall causes the overflow of the canal, causing a flood in the road, as you can see here. Now, these phenomena will have impacts on the water quality. In our reservoir, we are seeing changes in the dominant species, different dominant species of algae, right? That actually produces the taste and odor issues. We are also seeing changes in the seawaters that actually causes there are many different nip tides that causes a high turbidity and chlorophyll A changes. And likewise, whatever happened here, the water that you use, right, will eventually impact the new water or the recycled water, whereby the rate of fouling, the fouling potential increase in our membrane. So this has to be taken into considerations, as we see changes in our environment, and whether or not, right, our current treatment plant can be able to handle. Like I said, in the whole water so-called loop, water treatment plant is the final barrier, to protect the water, the drinking water that is sent to the consumer. So it's very critical for us to understand the changes in downstream of the water treatment plant, right? Where we have instituted policy and changes and technology, or incorporate technology to mitigate the pollution in the catchment, right, and try to maintain the quality. But this we can only so too much. We can still see elevation. That means that the quality of our salt water are creeping up day by day. Over the years, our TOC, the total organic carbons in reservoir, from a level of 2, it has risen to sometimes 9, sometimes even 10 or 12. Now this has created concern now whether or not the current existing treatment schematic, at the conventional treatment stream is able to handle. No, it doesn't. So we have to think about how do we then upgrade existing infrastructure, right, to be able to handle the quality of the source water that is coming in. So over the last 10 years, all our treatment are undergoing upgrading. Where the plants are newer, we do upgrading. Where plants are older, we are actually going into total renewal. Now, as an example of upgrading, right, this is a plant that in Choa Chu Kang, whereby we are actually tightening up our separation technology from sand filters to membrane. We have immersed membrane, whereby we do retrofitting. We have to retrofit in existing plant because some of the infrastructures are still usable. That means they have not reached their useful lifespan. We have to look at upgrading, where if you look at the lower phase 2 of this plant, we have land, we can open up new land to incorporate new technology, right? We also have to look at the disinfection process. Is chlorine, like chlorine disinfection, still the better way to do it? As you know, that as the organics rises in numbers, right, it formed the precursor for THM in the drinking water. So we need to change to look at a more efficient way of disinfection. So we have chosen ozone. And coupled with ozone, right, we need to introduce new process, right, to take away the similar organic carbons that are oxidized as the DOC got passed to the oxidation stage and turn into a biodegradable organic carbon and turn into a food for system. So we introduced biological active carbon or GAC carbon filters, right, to absorb or to consume the carbon, the biodegradable carbons, right, to prevent it from entering the system that become a food for bacterial regrowth in the system. So these are the changes that has been going on in our treatment plant, and by the next 5 years, all our treatment plant will be deploying with membranes, filtration, ozone, and BAC combined system. Okay. So this is one example of the retrofittings that I mentioned about. We have an existing plant that is using sand filter, and we have to remove the sand from the filter and convert it into a submerged membrane. In these ways, we try to reduce the cost of introducing new technology, but rather incorporate new technology into existing plant. Here is a greenfield site whereby we have the opportunity to deploy the most latest technology, right? That can provide the optimum efficiency in a water treatment plant. Here I'm showing you is the ceramic membrane that has been built at our CCK plant. It's a 40 mgt or 82,000 cubic meters per day's plant. This particular technology is selected not because straight from the market, but rather we spent about 10 years going through a research and development process of piloting and demonstration with our collaborators to validate the performance of the technology before we actually implement and build a large scale. And this is the result of a 10-year research and development efforts, right? That we decided that we go on full scale on this plant. And the ceramic membrane proven to be more robust, and it actually are able to deal with very aggressive water with high TOC. For example, I think even our polymeric membrane, right? It has a limitation on the DOC level. Once the organic passes a certain level, right, you actually foul the membrane. But in case of ceramic membrane, it can actually withstand a high input of organics, right? And yet we can treat it with without any problem. So this is the advantage of the ceramic. So you can see the upgrading has in the plants that incorporate all this technology. Switching to ozone, replacing chlorine disinfection. Now here is a slide that actually try to demonstrate the upgrading whereby we adopt new technologies that improve the performance, that help us to minimize our footprint. As you know, Singapore is tiny. Every inch of our lands are precious. So we are also looking at technologies that really have a small footprint. Now in this case here, in the left of the picture, you will see the ozonator that we had, right? It is a 12 such generator, which is a huge generators, right? That produce that for a 362,000 cubic meters so-called plant. On the right-hand side, you can see that all these 12 has been replaced by just 3 tiny generator that occupy probably a tenth of the room that is originally occupied by the old generator. So this is to illustrate the adoption of technology, not only in advanced, but also look at technology that are able to provide the same efficiency with a smaller footprint. Right. This slide that we have also built a BAC filters. And this is, like I said again, it is an additional process that added into our conventional treatment process, right? To actually provide the capacity or capability, right, to mop up the organics that will cause regrowth in the system and render the water more stable in the network. So, as I said, leveraging of technology is an important effort in PUB. right? So how do we do it? Looking ahead, if you look at Singapore demand, Singapore water demand currently is at 2 million cubic meters per day. We estimated by 2060, right, that demand will grow to 4 million cubic meter a day. Now, as I said, as far as the land storage is concerned, there's no more space for us to store, and we have to rely more on our recycling and desal plant to provide that additional capacity. Right? To do that at current cost of energy, right, it will be astronomically expensive. So if we were to do nothing and continue our current practice of desalination and recycling, and when we reach 260, right, that water cost will be 10 times more, maybe more. So our long-term goal really is we have to look for technology that is able to provide us the capacity in 2060, but still at the cost of current energy and also at its current footprint. This is a challenge that we have to achieve by 2060. So we have to come up with a plan, and that is to invest in R&D, right? As we move towards the future, right, it is not easy for us to go to the market and off the shelf and pick up a technology and say, this is going to do, because different country and different requirements. So manufacturers do not tailor-make a certain technology just for you. And PUB realized that, and we need to drive certain technology that is going to fit our needs. And I call it fit for purpose. And that is where the government's effort has chipped in, right? The National Research Foundation of Singapore, right? To push on the R&D investment under the water sector. We started this way back in 2022. And up to today, we have actually done 661 projects in and spent $700 million of investment, right? To create, these are, so what I said earlier in terms of the BAC filters, ceramic maintenance is part of the outcome. The variable desalination plant is also part of this effort, right? And we have a roadmap that actually encompasses all categories of technology that included the drinking water segment, but it also includes, like you see, coastal protections, water quality, management of our network, the used water network, the drinking water network as well. So this actually, this roadmap forms the footprint, right, for us to drive the technology, the technology that we require in the different path. And I say, we have to now drive in order to achieve the capacity in 2060 at the current price, right? We need to drive the energy cost of water from the current of 2.53 actually now it's 2 kilowatt, eventually hoping near to 1 kilowatt. And likewise with recycling, we need to drive the energy down so that we could be at less than, probably hopefully less than 0.1 kilowatts. And we are doing projects that perhaps can combine like you can see at MBR, we are into the MBR so that we are combining 3 processes into 1 process. So these are the efforts that are currently ongoing, right? And then of course, having done all this, when you introduce this at the system level, right, with all the advanced technology that we employ, right, these are not easy process that we can just manually handle. You have come to a stage whereby every process, right, like the membranes, right, it is fully automated. But if you put every process together, 10 processes in 1 basket, and each of them have their own automated system, right? At the system level, they will not be able to run optimally. So we have to go into what I call a full automation control of the system at system level. Digitizations is one way, right, to have a full control of at the system level, to manage the process independently and as a single system. So a lot of research are going into digitalization as well. And that comes up with a roadmap that image the water loop, but we have what I call a smart PUB roadmap. So I'm going to give a few examples of the things that we are doing now. AOP pilotings, currently we do not use AOP at the moment, but it is not something that we will not be using. It probably will be using it if the control in the water quality from the source, right, continue to deteriorate, then there may be times that we will need to introduce additional process such as AOP. So instead of waiting until the time, we are actually planning ahead. So we are doing research, demonstration and research work to actually come up with a drawer, I call it a drawer plans, so that we can size up the dimension and also the specification of an AOP process, right? And work out the land size. So in all our new plants, like our new recycling plant, spaces are allocated for AOP. In the event that in the future, 10 years, 15 years down the road, right? If this process is needed, right? We already designed to plug in such a process into the existing plant. So the existing plant will be designed to be coupled with the AOP when the time needs it. Right? We are also looking at different membranes, membranes that are able to do much more efficiently than the current membrane. And I think later on, probably Prof. would talk a little bit about the work that NUS is doing, that's working with PUB. So I won't go too much into this. So we are also looking in membrane material, the membrane constructions, right? Ceramic membrane already successfully tested in the drinking water. So we are also looking into ceramic membrane application in distilled water. As you see on the top of the schematic, I've drawn a coupling of two processes, DAF and the ultra filtration. There is a possibility that if this is successful, right, we probably can do away with the two processes and just combine them into one process. Again, that will help to save energy, and also in this process that we are driving to lowering the energy. Right. Closed circuit reverse osmosis is another technology we are exploiting to help us to improve our energy in the desal plant. So again, here you can see that we have been working on this particular for some time, and it has been coming up with quite promising results. And the next step is that we'll be coupling this into what I call it IVP. It is a demonstration plant that we will couple all the technologies that we have tested, right, into a single system, and then we'll validate the number from the piloting that we've gotten. Right. Again, there's another membrane-based, aquaporin-based membrane that we are exploring. Right. And you can see on the graph that the difference between the current commercial, the energy use, between the AO from the aquaporin-based membrane. So there's so these are what I've said is our water treatment based. There are others technology, like I said, we have done 661 projects. So among those, some are listed here as well. So we've done project like monitoring, water quality monitoring, as and and in the used water side, we even going into a GPS-less environment, flying a drone into a deep water pipe tunnels to inspect the tunnel. So these are the various projects that currently POBs are doing, and these are from a few which I want to highlight to you. Right. So I'd like to touch a little bit on the ecosystem. I can see here, Singapore is a very small country. As we push research work, maybe it's best if I analyze, do an analogy. In a Toyota, let's say take a car company, a Toyota. The Toyota company design a car. So when they want to produce this car, right, they are dependent on hundreds or thousands of small and medium-sized companies that produce all the parts for them to put together, and they need an integrator to put the parts together so that to form the actual car that it can drive on the road. While the car is driving on the road, you need a workshops, mechanical workshop, right, to help maintain the car. So water treatment plant is like having a car, As we build up our water plant system, right, we need to have an ecosystem of industry that can support the plant, right, in terms of providing new technology, right, integrating the technology, and also support industry to support the operation of the plant. And this is an effort that work together, that the Singapore government on the top-down basis, right? The Economic Development Board, you have the NRF, the National Research Foundation, and PUB. We all work together to build an ecosystem that can be able to support the water industry, right? So here you see here that over the year, we built up that ecosystem with overseas partner, with local startup, and so on. And this is critical for the health of the water industry, and also for the efficient and cost economy operation of our water treatment plant, right? Of course, we need skilled workers. Having built up that ecosystem, the ecosystem has to be staffed by skilled worker, and we pitch in. We're not counting NUS and NT and all this. Singapore also pitch in, to build avenue for startup to set up the company, and also a training center, right, to train, our Singapore Water Management Water Academy actually conducted courses, right, to our own POB staff and as well as the industry. So the next course that is coming is water reuse, and I know this Ian Law, one of our partner from Australia, who is very experienced in water reuse. I think he will be teaching on this one. So from 11 to 14 April, this is another efforts in terms of the overall so-called management system that we're trying to build in to incorporate the training part as well, right? And lastly, before I end, right, is how do we interact? And then in the Singapore International Water Week is one avenue whereby we're able to bring everybody together, and through this interconnection, context, right, it will help to foster the overall wellness and health of the ecosystem that we're trying to put in, right? So I think this is my last slide, and the International Water Week is happening also in April, and we are trying to do it as a physical meeting, and hope that all of you will be able to attend, right? So all I've said here is just a snippet of what is already written in our publication. I've actually listed out recommended 3 publications published by POV, whereby a lot of the information in our research innovation and the way we operate the water treatment plant or our water management system are all listed out here. So you can actually go and download the this publication, and it will explain in much greater detail that I've done so. So I think this is end of my talk, and I'll thank you very much. I'll take questions later on. Thank you very much.
Yeah, thank you, Mr. Pua, for sharing the whole the experience within a couple of minutes. So it's a wonderful presentation. I very much like the terminology used to hard and hardware. So you were able to convince us on this hard and hardware through your presentation. Thank you very much, Mr. Pua. I think we will continue your sharing with the discussion. Many questions to Dr. Veragoda and Mr. Pua, and also question to Professor Hu. So I saw that Dr. Veragoda was answering the questions. Yeah, I will move to the Mr. Pua, and I will come back to Dr. Veragoda later if we have a time. Yeah. So, Dr. Pua, there was a question that's in Singapore. They use 50% of the rainfall collections, and the rest is going to the sea. But the strategy is we use used water for recycling. So the question is there any opportunity cost for recycling the used water, or the recycling the rainwater, that is, we let it to go to sea? What is your experience or thinking on this one? Mr. Pua, you got
okay.
Got the question?
Let me explain. I think correct it. I think when I said use the analogy of the glass, right? Full, and then it's not 50-50. It's definitely less than 50% that is lost to the sea. It varies, from time to time, it could be 10% to 20%. I don't have the exact number, but we do have, when heavy downpour, we have to let go some water. Now, to his answer to the questions, why not we build, instead of treating the used water, recycling it, why not we catch the excess rain? The question is, as I said, we already use up all the land that is possible for building storage. Now, whatever excess rain, there's no way for collection anymore. That is the max. That's why I use the glass as an analogy. It's already full. Any excess, right, you pour in the same glass, right, it will still overflow. I do not have a second glass. However, right, in our whole water system, we need to collect all the used water, right? And we also need to treat those users before we can throw it into the sea. So this is a natural hydrological cycle. So what I mentioned in my loop is that we can short circuit that. Whatever water that has been treated to be thrown into the sea, I can draw it out and into a plant immediately. That means that it's a real time. We are talking about real time. There's no storage. Whatever the wastewater treatment plant produces, right? We extract out from the effluent pipe and go straight into a recycling plant and produce the water straight into the distribution system. So there's no storage, and that is how we could do it. Otherwise, note that otherwise we will need storage, and that is something we cannot do. I hope that I answered the question.
Yeah. Okay. Thank you, Pua. Yeah, and yeah, there are some few more questions. I will come back to Mr. Pua. Professor Hu, there is one question. In this removal of micropollutant using UV AOP, the organic matter presence would be a hindering. So how do you deal with that one?
Okay, I saw this question coming from Elling, our friend also. Okay, yeah, it's a small word. Okay, definitely, this is a very nice question. I think anybody doing this, AOP process realize that the organic matter's presence, the natural organic matter, is going to impact on our downstream AOP process. So no doubt on that. Actually, we have negative impact. So to enhance your AOP process, our suggestion is you need to have a certain pretreatment, okay, to somehow control the impact of natural organic matter, so that I think when it moves to the downstream, then you have much less impact given by natural organic matter. So, and bearing in mind the UV AOP or other AOP processes, they are energy intensive, and you don't want to use this energy for some other organic matter like natural organic matter that much, and you want to deal with those emerging organic contaminants. So the natural organic matter need to be somehow taken out or reduced to a large extent before it comes to your AOP process. That probably is the way to go.
Yeah, thank you, Professor Hu. And then I'll move to Mr. Pua. There is a question from Sri Lanka. What is the Singapore experience to reduce the per capita water consumption?
Okay, I thought I answered that. Okay, the per capita, this is more on the hardware, which I didn't go into.
Yeah. We want to listen from you.
So actually, this is a few effort really from the regulatory ends. We actually mandated the use of water saving devices, and low water usage, like the water system. We have limit the volume like 14 liter or 1.4 liter. Then we also developed jointly with technology provider shower head, special shower heads that actually tell the users, right, whether they're overusing the water or not using water. On the more broader way, smart water. Now, smart water is beyond AMR. It is a device that not only registered automatically the readings, but also monitor the behavior of the consumer in the household. They will know how much water is using for washing at what time, and also on top of that, it also monitor whether there is excessive usage and whether this excessive is normal. If it's normal, that means that they will send out a message to say there's a leak. There may be a leak in the system. So with all this effort, including education, we do a lot of education to talk about how people can save water. So through this, right, that is the effort for reducing the per capita income. I think currently we are at 2,400, is it? I can't remember the actual liter because I'm not in the hardware part. So these are all the efforts that we do, in the reducing per capita consumption.
Yeah, thank you. Thank you, Professor Mr. Pua. That's very interesting. I have one question that's my question to Professor Hu. We understood that one solution become a problem. We try to solve a problem in the sanitization, and that become a problem in the wastewater treatment. So these solution and the problems, these loops are going ahead. So what is your opinion, Professor Hu, on this regard? One solution lead to another problems. Are we going to continue this, or what is your thought of it?
So thank you, Professor Maju. Right? I mean, the solution I just now propose is one kind of the solution. There could be some other solution as well, but any solution is not going to be perfect. You just look at this AOP process. It can be very, very efficient, can be highly, highly effective. You can get 90%, 95, even more than that in terms of removal or inactivation. But don't forget about energy consumption in this particular process. So it's, as you said, one solution lead to another problem. So energy is one key issue, for people in this AOP process field. We are actively looking into that, and there's a possibility to lower down the energy, right? If we make use of the sunlight instead of UV light, or if we make use of some other newer type of the UV sources, like just now I mentioned about UV LED. I don't have much time to touch on it, but we actually already started looking into LED process involved in the small scale, even medium scale water treatment process, to lower down the energy consumption in this particular process. So I think you are right. I think we have definitely gotten some issues associated with our solution, but I think the water industry and the water professional people are working very hard to address those.
Yeah. Thank you for that inspiring answers. Yeah. There's another questions to all panelists. Even the participant also can answer. The capacitive deionization (CDI) technology for treating water. Anything any panelist can share the experience on these CDI technologies?
PUB site actually has done some work on this capacity deionized technology on the membrane. So far, I am not too sure because I'm not involved in this particular technology, right? We have not had too much success during our research work. Perhaps somebody have better success.
Okay, all right. Others, yeah.
I see Jocelyn want to answer, right?
Okay, so Jocelyn.
Maybe to just finish off with the remaining question here. Yes. Because we are running over time already.
Yeah, exactly. Yeah. Okay, right. Okay, so yeah, thank you very much. And there were some more questions due to the time limitations. We are very sorry. And there were questions that panelists already have answered. And yeah, thank you very much for giving this wonderful exercise on this wastewater treatment and the management, the sharing the experience between these 2S, Singapore and Sri Lanka. So thank you very much for all the participants. Actively, you contributed a lot in this discussion. Now the floor is to Dr. Lai. Thank you, Dai. Yeah.
Right. Thank you, Professor Maujud, and thank you for all the speakers and panel members for this afternoon session. Yeah, so we have come to an end for today's webinar. So I hope that you have had a wonderful session. We look forward to seeing you again in the next webinar. Do keep this, you can scan the QR code and bookmark the web page here where we put our full program. We will be putting up further webinars that we have on this page as well. And we will keep you informed of our next and up and coming webinar soon. Thank you and have a nice day. Thank you all.
Thank you.
Thank you.
See you.
Thank you, everyone. Bye-bye.
Thank you. Bye.